We will talk about basic derivative rules. First of all, let me introduce the functions involved. The first function fx, which is considered to be x plus 1. The second function gx considered to be x squared. And then c is a constant. C is a constant. Now, when we go to the constant rule is ddx of c is equal to 0. Now, first of all, we have to understand this ddx is the operator. We call it differential operator. And this operator is acting on c, which is a constant, and the output would be 0. So now how to understand this? Suppose we have a constant value in xy plane. Suppose that constant value is 5. So here c is equal to 5. Now we know ddx of a function gives you the slope. Now what about the slope here? Slope here is equal to 0. So that will tell you that ddx of c should be equal to 0. Why? The slope is equal to 0. So now that is all about the constant rule. Now next one would be constant multiple rule. So for example, ddx of cfx. So this function is multiplied with c. So if you have a situation like that, we can take c constant out and we can write c ddx of fx. Now in our case, c is equal to 5. So example, ddx 5, my fx function would be x plus 1. That is equal to 5. You can take the constant out, ddx x plus 1. So from here, you can say ddx x plus 1 is going to be 1 here, essentially. So how do you obtain this one? I will teach you in my next video. But for now, we will understand the rules. So the next one would be power rule. So the power rule talks about this. ddx x to the power n is equal to nx n minus 1. So when I'm talking about the techniques in the next video, I will explain this more. But for now, so we will try to understand this. So let n, the power, we will consider n to be 5. So as an example, ddx of x to the power 5. So that can be written as 5x4. So now we will move into the next one now. The next rule would be summation rule. So let me write it down. ddx of fx plus gx. So it would be like this. So if you have a situation like that, this operator is acting on the fx function as well as the gx function. So you can write it in the split form. So ddx of fx plus ddx of gx. Now, as an example, ddx, your fx function is x plus 1 plus gx is x squared. So if you have a situation like that, so this is your fx function. So we will consider this fx function separately and the gx function separately. So once you get the derivative of these two functions, you will get 1 plus 2x. So this part I will teach you in my next lesson. Now the next rule is the difference rule. So the difference rule is similar to the summation rule. The only difference is the minus sign. So ddx of fx minus gx. This can be written as ddx fx minus ddx of gx. Now here this operator is acting on fx and ddx operator is acting on gx in this case. So now as an example, ddx fx would be x plus 1 minus x squared. That would be your gx. So this can be written as ddx x plus 1 is your fx minus d dx of x squared. So now the solution for this one would be 1 minus 2x. Again, this will be discussed in our next video. Now we will move into the product rule. So this is one of the important rule in differentiation. So d dx, the operator, is acting on fx multiplied with gx. So here d dx is acting on this fx times gx function. So if you have a situation like that, the rule says we can write fx and then the derivative of the second function, which is g dash x, plus gx, the derivative of the first function. So now you know g dash x is nothing but d dx of gx. F dash x is nothing but d dx of fx. So now we will try to understand using a question. So fx function is x plus 1, gx is x squared. So this is your function now. So fx would be x plus 1. So I'm going to apply the rule. Here d dx of x squared plus x squared, you keep it out, and d dx operator is acting on x plus 1. So now, as you know, d dx of x to the power 2, the answer will be 2x. Again, this will be taught in my next video. D dx of x plus 1, the answer would be 1. Then you can collect these terms and then you can give the final answer as this. Okay. So if you want to further simplify, here it is going to be 2x squared with 1x squared. It's going to be 3x squared plus 2x is the answer. If you want to get the common factor x out, then it's going to be 3x plus 2. So that would be the answer to that question. Now we will talk about the division rule. Another very important rule in differentiation. So if you have d dx, fx function divided by gx function, if you have a setup like this, so this is how the rule works. So you have the denominator dx, so denominator squared. Then that denominator should come here, gx, after the derivative of the numerator function, minus, you keep the numerator here, and then derivative of the denominator function. So this can be written as gx, this would be f dash x, minus fx, this would be g dash x, the whole thing divided by gx squared. Now, as example, d dx of fx function would be x plus 1, and then gx is x squared. So if you have a system like this, this is going to be x to the power 4, because the square of the denominator function. Then x2 goes here. Then d dx of x plus 1, always minus. Then x plus 1 comes here, and you do the derivative of the other function x squared. So here you get x squared, d dx of x plus 1, that is going to be 1, minus x plus 1 comes here, then d dx of x squared, this is going to be 2x. The whole thing divided by x to the power 4. Now you can see x is a common factor here. So you can take x out from the numerator. So you get x here, and then minus 2x plus 1, the whole thing divided by x to the power 4. So here you can cancel 1x with here with x's you can cancel. So 1 divided by x to the power 3. Now here inside the bracket you can simplify a little bit. X minus 2x is going to be minus x. Minus 2 times 1 is minus 2. So if you want, you can take minus out, minus 1 divided by x to the power 3. Then the answer would be x plus 2. So this would be the answer for that example. So now we will discuss the chain rule, which is very important rule in differentiation. And in my next video, I'm going to explain more about this chain rule with more examples and with few tricks so that you can easily recognize the functions. So this is all about the composite functions. So first of all, we will try to understand what is f gx. What is this? Now we know fx. Fx is equal to x plus 1. And we know gx. So this is our example functions, x squared. Now when you write f gx, we can understand this x is replaced by gx. You can see the parenthesis here. So inside the parenthesis, you have gx here. Here you have x. Now this will tell you, if you have x here, that x variable should be here. So with that logic, you can understand if gx is here inside, gx should be here. So that function can be written in that way. So when you have x here, you have x in the right hand side. Now if you replace x by gx, so gx should be here. So f of gx would be gx plus 1, which is gx is x squared plus 1. So now the rule is this: ddx of f g of x, it's a composite function. This would be f dash gx times g dash x. So this is a little complicated here, and we will try to understand. So f dash gx would be this: d g dx, d dgx. Here you have f gx. That's the right meaning here. So you are taking the derivative with respect to gx now. Before we had the derivative with respect to x. So this is a construction. So I'm going to teach you this construction in my next video so that you can understand better. Multiply it by what is g dash x, that would be ddx of g. So this part is this, and then this part is this. Now, theoretically, this is a little rigorous, but in my next video, I'm going to concentrate on this more, and then I'll show you a few tricks so that you can easily understand how to use the how to use the chain rule for composite functions.